Day 106 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. This time we're at day 106, y'all. We've really been locking in. We've really been staying disciplined. So if you've been following the channel, get excited about that. Give yourself a pat on the back, especially if you've been keeping up with me day by day and you've done all these 105 previous problems with me. And now you're on day 106 as well, because that is a big accomplishment in and of itself, just because you were able to stay disciplined and stay consistent. A lot of people aren't going to make it this far just because they don't have the discipline or they're not motivated to stay consistent. But guess what? We are, and we're going to keep going. We're just getting started. But before we get started, y'all, don't forget, bring your mouse right over here and click that subscribe button for me, y'all. Then after you click that subscribe button, go ahead and smash that like button for me, y'all. Then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need you to drop 2 bank emojis in the comment section so we could run up this engagement and we could help get this content out to a broader audience and do our part in helping the Swift community grow as a whole, y'all. We're all here together. We're all here to help each other up. We're all here to work together, and we're all here to help build this Swift community, y'all. So we have to do our part, and in order to do that, we can help get this content out to more people. So with that being said, y'all, I know why you're here. And today we have question number 3,162. Find the number of good pairs 1. The difficulty level is easy, y'all, so you already know we're going to keep the solution as simple and easy to understand as well. Now, let's see what the question says. It says you are given two integer arrays nums1 and nums2 of length n and m respectively. You are also given a positive integer k. A pair ij is good if nums1I is divisible by nums2 of j times k. And then the 0 has to be less than or equal to I. I has to be less than or equal to n minus 1. 0 also has to be less than or equal to j, and j has to be less than or equal to n minus 1. Return the total number of good pairs. So let's break this down and see what they're talking about, y'all. So we have input nums, an array of integers 1, 3, and 4. Nums1. Then we have another input nums2, an array of integers, again 1, 3, and 4. And k is equal to 1. The output is 5 because we have to find all of the good pairs where each number in this has to be divisible, or this has to be each number in nums2. What does it say? No, each number in nums1 has to be divisible by nums2 of j times I. So let's break it down so we can really see. Let's look at the good pairs. These are the 5 good pairs right here. So let's go through them. So first we have 0, 0. So we have 1. Then we have over here we have 1 times 1. So is 1 divisible by 1 times 1? 1 times 1 is 1, right? So is 1 divisible by 1? Yes, it is. So that's a good pair. Then our next good pair is 1, 0. So this is 3 and 1. So again, we have 1 times 1. So it's 3 equals 1. So is 3 divisible by 1? Yes, it is. Then we have 1 and 1. So we have 3 over here, and we have 3 right here. Now it's 3 times 1, which will give us 3. Is 3 divisible by 3? Yes, it is. Then we have 2 and 0. So we have 4, and then we have 1 times 1 equals 1 again. So is 4 divisible by 1? Yes, it is. Then we have 2 and 2. So we have 4 and 4. So over here, so 4 times 1 would give us 4. Is 4 divisible by 4? Yes, it is. So that counts as a good pair. So let's look at example 2 just so we can really make it make sense. Over here, it's only 2 good pairs, so we should get through it pretty quickly. Let's look at it. So we have nums1 equals an array of integers 1, 2, 4, and 12. Nums2 has an array of integers 2 and 4. K equals 3. The output is 2. The explanation says the 2 good pairs are 3 and 0 and 3 and 1. Excuse me, y'all. So let's break it down. So let's go to index 3. So we have 0, 1, 2, 3. So we have 12. Then we have over here, we have 2 and 4, right? So first it says 3 and 0 are good, so let's make sure. So we have 12 and 2 times 3. So K is 3, this is 2. So 2 times 3 will give us 6. Is 12 divisible by 6? Yes, it is. Then we have 3 and 1. So this time it would be 12 and 4 times 3. 4 times 3 is 12, so it would be 12 divided by 12. 12 is divisible by 12, that equals 1, so that's another good pair, 3 and 1, and those are our good pairs. Anything else? Let's look at an example of a pair that wouldn't be good so it can make sense. So say we had 1 and 2, right? And then it'd be 2 times 3. So it'd be is 1 divisible by 6? No, not really. So then let's say if we went over here to 2. 2 and we did over here it'd be 2 times 3 is 6. Is 2 divisible by 6? No, it's not. So that's not a good pair. Then we have 4. We come over to 4. 2 times 3 is 6. Is 4 divisible by 6? No, it's not. So it's not a good pair. Then we come down to 12. We have 12. And then we have 2 times 3 is 6. Is 12 divisible by 6? Yes, it is. Hence, that's one of our good pairs right here, 3 and 0. So now that we understand what the question is asking, let's get into the fun part, which is the actual code. And the code is not that difficult at all, y'all. The first thing we're going to do is declare a variable called count, and we're going to set that equal to 0. Then we're going to come down here, we're going to say for I in nums1, or excuse me, we're going to say for I in 0 up to nums1 dot count. Then we're going to open up the brackets. Then we're going to come down here and we're going to say for j in 0 up to nums dot count. Then we're going to come down here and we are going to say if nums of I, then we're going to come over here, we're going to say mod. So this mod, this is going to give us the remainder. This right here is looking for the remainder of what we're about to divide. So we're going to say open up the parentheses, we're going to say nums of j, then we're going to say times k, then we're going to come out here and say equal to 0, then we're going to open up the brackets. So what we're saying is if nums of I mod nums j times k is equal to 0, then we're just going to say count plus equals 1. Then we're going to come down here and we are going to say return count, y'all. And that should be all she wrote. Let's run it, make sure it runs correctly. But that should be all she wrote, y'all. Should be that easy. Ooh, let's see. We got nums1 dot count, and this should be nums2 dot count. So let's run it again and see how it runs. That should be all she wrote, though, y'all. If we could get past these, gotta do it again. Nums1 right there and then nums2 right there. So let's run it again, y'all. Hopefully this time it goes through. Fingers crossed, fingers crossed. And it's accepted, y'all. So let's submit it. Let's submit it, y'all, and see what happens after we submit it. Boom. 12 milliseconds beats 20% of users with Swift, y'all. Not too bad at all. This is a good solution to really get an understanding and build a foundation off of as far as how these questions actually work. So get one more look at the code, y'all. One more look at the code. It looks similar to some code we wrote the other day. One more look at it, y'all, and I'll see y'all tomorrow for another day, another LeetCode problem. Peace.